Alright, today we'll be working on 9.1 Properties of Radicals. This is part 1. Tomorrow we'll be working on part 2 of 9.1. Alright, so let's begin. So to begin with, make sure to copy down this core concept right here. It's really important. So it talks about using properties of radicals. So a radical expression is an expression that contains a radical. An expression involving a radical with an index n is in its simplest form when these three conditions are met. No radicands have perfect nth powers as factors other than 1. No radicands contain fractions, and no radicals appear in the denominator of a fraction. You can use the property below to simplify radical expressions involving square roots. Alright, so that was a little bit confusing, but in this video you'll learn a little bit about the rules and understand what these rules are. And so today we'll be focusing on the product property of square roots. And the product property states that the square root of a product equals the product of the square roots of the factors. So for example, say we have root 9 times 5, right? We can go ahead and separate these two, right? So we can do root 9 times root 5 is equal to 3 root 5, right? And where did this 3 come from? This 3 came from finding the square root of 9. The square root of 9 is 3, so we take it out and put it in the front. So the key point to remember here is that when you have something like this, right, the root of 9 times 5, you can separate those two into two separate square roots, right? So here's the rule in algebra form, right? And b has to be greater than 0. Okay, so let's try one to try this problem out. Okay. So we have root 108. So this one's a little bit tough. So what I like to do with this is first start off with the smallest number. So with root 108, we're going to do the same thing right here. So this 9 root 5 was originally root 45. It was root 45, and they divided it up into root 9 times 5, and you know where to go from here. So we're going to do the same thing with this one, 108. So figure out what we could plug in here, right? So what can we make this equal to? So we're going to find what goes in here. So there's two different numbers that could go in here and equal 108. So let's start off with a number like 2. So 2 times something is equal to 108. So that would give us 2 times 54. However, can we find the root of 54? No, there is no whole number root for the number 54. So we can't use 2 times 54. So we're going to try the next smallest number, 3. So that's what I like to do. I like to go from 2, 3, 4, 5, and so on. Right? And I use 2 for this one because I know that the last number is even, and so that means it's divisible by 2. So now, since we tried 2 already, let's try 3. 3 times something equals 108. Well, that's going to be 3 times 36. And now, what you're going to have to ask yourself is, can we find the square root of 36? Yes, we can. The square root of 36 is 6. But before we even do that, now we're going to create two separate equations. So we're going to write 3 times, oh, that's not cooperating with me here, 3 times root 3 times root 36. This is still the same thing, right? So from here, we can now figure out how to solve this problem. So if we take the root of 36, that would be 6. So our answer is going to be 6 root 3. So the key thing to remember is start off with the number 2 and then slowly increase your numbers. So go 2, then 3, then 4, then 5, and so forth. The goal of this is to figure out a number that would give us a square root of something, right? That's the goal. So we can simplify it. Okay, so now let's try another one. Let's try this one. Root 9x to the power of 3. So let's see here. Let's separate this out before we even start. So what we can do is we can do 9 times x to the power of 3. Right? Let's do that first. And then from here, what is the root of 9? Root 9 is equal to 3. Because 3 times 3 is equal to 9. And then, now we're left with x to the power of 3. And to solve this one, what we can do is, we need to figure out the same thing that we did last time, right? Here we figured out if we could get a root out of the number 108. So we can do the same thing here. Can we find a root here? That's what our goal is. So this is what we're going to do. We're going to do x times x to the power of 2. And here, we can go ahead and separate these as well. We can separate to 3 times x to the second power times x. And from here, we can now find the root of x squared. The root of x squared is x. And we're still left with this root x right here. So we're going to put that right there. So the final answer is 3x times root x. Now we're going to move on to the next problem. Before we begin, here's the core concept for it. So for this one, we're looking at the quotient property of square roots. And this one states that the square root of a quotient equals the quotient of the square roots of the numerator and denominator. So for example, here we have root 3 over 4. This can be separated into two separate pieces, right? The top part is going to be root 3 and the bottom is going to be root 4. Notice in the beginning, it was the root of the whole thing, and now we're separating it. And when we do that, we can figure out that root 4 is equal to 2. So this would be the simplified version. So now we're going to try the same thing with root 15 over 64. So go ahead and pause the video and try to do it on your own first. So what we're going to do here is let's separate it out again. So we're going to separate the top part, root 15, and we're going to give each, the top and the bottom, its own root symbol. So we have root 15 and root 64. And we notice that we can't simplify root 15 anymore, right? Because even if we did this, 3 times 5, we notice that we cannot find the root of 3 and 5. So we're just going to have to leave root 15 by itself. But can we find the square root of 64 though? Yes, we can. The square root of 64 is 8. And that will be the final answer. Let's try a different problem now. So now we're going to try a problem that has a cube instead of a square root this time. So now what we're going to do again is very similar to what we were doing earlier. We're going to break this down again, negative 128. We're going to try to simplify it. We won't be able to simplify the whole thing, but we can get some of it outside of this radicand. So once again, we're going to try the number 2. We always start with the smallest number possible, see if we can find a square root in there. So let's start with that. So we're going to try negative 128 divided by 2 is negative 64 times 2. So from here, we can separate these two pieces. into negative 64, root negative 64, not root, cube root of negative 64. Okay. And then from here, now we need to figure out what number multiplied by itself 3 times will give us negative 64. And that's going to be negative 4. Negative 4 to the power of 3 is negative 64. And we have to bring down this piece right here, and then that's going to be our final answer. Let's try another one. This time it's going to be a fraction. So remember what we were doing earlier. Let's go back to this problem right here. We're going to be doing the same thing as we were doing right here. Right? We're going to divide it up into 2 pieces. The top and the bottom is going to get its own radicand symbol. Okay, so let's go ahead and do that. Remember to bring the 3. All right, so now what we're going to do is we're going to separate this out into smaller pieces again. So we can see if those smaller pieces could possibly have anything that we could simplify. So we can take this 8 out, right? So 8 times, so we have x to the power of 4. Well, knowing that 3 plus 1 over here is also equal to x to the power of 4, we can do this. X to the power of 3 times x to the power of 1. And by doing that, we can take this out, right? The cube root of x to the power of 3 is just x. So we'll do that over here. Put an equal symbol right here. And we're going to take let me do this over here real quick. So we can take the x out. We have that so far. And we notice here that we can, actually before we do that, let me erase this and we'll do this at the end. Alright, so once again, separate it out. See if you can identify any cubes that we can make from here. And now, let's do this. 27 times y to the power of 3. So now, pause the video and see if you can separate yourself now. We're going to give each piece its own. This is still the same equation. Nothing has changed. This equation up here is still the same as this down here. Alright, so now we're going to simplify this. What is the cube root of 8? That is 2. 2 to the power of 3 is equal to 8. And then if we simplify this, we're left with 2 times x, right? And then this cannot be simplified any further, so we're just going to bring that down. We're going to leave that alone. And now we need to finish the bottom part right here. So then this simplifies to what? Let's see. 2 to the power of 3? No. 2 to the power of 3 is 8. 3 to the power of 3 is 27. So now we can write 3 out here. And then this simplifies to just y. And now, let me erase this. So this is going to be our final answer. All right, let's try another one. So now we're going to try rationalizing the denominator. So when a radical is in the denominator of a fraction, you can multiply the fraction by an appropriate form of 1 to eliminate the radical from the denominator. This process is called rationalizing the denominator. So what we're going to do here is, let's try this problem. So we want to get rid of this radical sign symbol on the bottom. So how are we going to remove this radical symbol? Well, what if we just multiply it by the same number on the bottom? And that's what we're going to do. So we're just going to multiply it by root 3n. But if we multiply the bottom by root 3n, we need to multiply the top part by root 3n. Right? And if we do that, we'll get rid of this radical symbol. And that's the goal. So what is root 5 times root 3n? That is root 15n. And then on the bottom, let's see here. On the bottom, we have root 3n times root 3n. So now, we leave the top part by itself for now. And then we're going to multiply this out. 3 times 3 is 9. And then n times n is n squared. 15n cannot be simplified. And then we have 9n squared. From here, we can separate those two. And this will give us root 15n. Root of 9 is 3. And then we have n squared, which is equal to 3n. And notice that this 3n is the same one over here without this symbol. So when we multiply it by itself, we get the same answer without the symbol though. However, this method will not work in all cases. If you have something like this, it's going to be a little different. So we are going to be multiplying again, but this time we need to figure out how we can turn this 4 into a number that we can cube root. So let's try a couple different ideas real quick here. So right now, if we do the cube of 4, or I mean the square of 4, we'd have 2 to the power of, 2 times 2, right? And this would be equal to 2. But if we want to find the cube root, how many times do you think we would need to have 2 to equal something in here? So in this case, it wouldn't be 4. It would be something else, right? So let's try 2 to the power of 3. So let me do this over here. 2 to the power of 3 is 2 3s. 3 2s. 2 times 2 is 4, and 4 times 2 is 8. So if we have that, it's the same thing on the top, just another 2. So how can we get it so that we can also add another root, something else in here that'll give us the cube root of 8? So what we're going to do is we're going to multiply the top and the bottom by the root of 2. Radical 2. And by doing that, let me see this. Let me erase this part over here. So remember, the goal is to get rid of the radical symbol. And by multiplying cube 2 right? The cube radical of 2, we get this. And on the top, we're left with 3m and this. So now, let me fix this. Now the cube of root 8 is 2. So we're able to get rid of this symbol down here.